So whether we're talking about a geometric or an arithmetic sequence, both of them have a couple different ways of notation for writing those sequences down. And one of the ways is the recursive method, right? So this is a quick review of how we write down sequences and describe them recursively. The basic idea of recursion is that you need to know how the sequence starts, and then you need to know how to get to the next term in the sequence. So two things are needed, right? We need to know the beginning, and we need to know the rule that goes from one term to the next term. Well, for this particular sequence, you can see the beginning is 2/3. So one of the things we would write down for the recursive definition is that the first value in this sequence is the number 2/3. So that's the first part, right? Where do you begin? The next thing we need is our recursive definition. And basically this is what it looks like. It says, hey, in order to get to the next value in this sequence, what you're going to do is take the current value you're at and you're going to do something to it. Now, as I look at this, right, what I'm doing here is I move from 2/3 to 2, 2 to 6, and from 6 to 18. Each time I'm multiplying by the number 3. So my recursive rule is in order to get to the next value, a sub n plus 1, I'm going to use my current value, a sub n, and I'm going to multiply that by the number 3. So that's my recursive definition here. Basically, I've got our starting point, and I've got how do I move to the next value in that sequence. Something similar notation for an arithmetic sequence, it's pretty much the same, right? Again, I need to know what my first value is, and here it's -10. And I'm pretty sure that our textbook uses t sub 1 for recursive one, and it uses a's for recursive. That's not magical, and it's okay if you use either variable. But the important thing is I'm saying, hey, the first value in this sequence is the number -10. And then I have to have the recursive rule, right? How do I get to the next term if I know what my first term is? Now you can see right here, if I'm going from -10 to 2, and then from 2 to 14, and then from 14 to 26, each time I'm adding the number 12, right? I'm increasing by 12. Even from -10 to +2 is an increase of 12. So that's the recursive rule, right? In order to get to the next value, right, t sub n plus 1, the next one is equal to the current one, t sub n, plus 12 more. So recursive definitions do need both statements. You need to know where to begin and how to get to the next term given the current term. And one of their limitations is it's difficult to jump. For example, if I wanted to jump to the 100th term for either of these, it's difficult to do that in one step because in order to know the 100th term, I need to know what the 99th term is. And in order to know what the 99th term, I need to know what the 98th term is. So in order to figure out any particular term, I need to know all the terms that come before it. So that is definitely a limitation. However, it can be much more straightforward and simple to write down recursive definitions as well. And if you're in an environment where you're using, computers, for example, to figure out what a particular term is, it doesn't really matter. If you're using a recursive definition, the computer can do things so quickly that the recursive definitions typically work just fine for us.